Alright, so the last type of special discrete probability distribution we want to consider in this review is the Poisson distribution, okay? So the Poisson distribution is used as a model for describing the number of times some random events occur independently in an interval of time or space. Now, the given time interval can be of any length, such as a minute, a day, a week, a month, or even a year. For example, the number of telephone calls received during a given period, the number of machine breaks down during a given day, the number of customer arrivals at a checkout counter during a given minute, or the number of plants growing per acre, okay? So the only assumption needed when one uses the Poisson distribution are that the events occur randomly and independently of one another with a constant mean, okay? The Poisson probability distribution is characterized by a single parameter lambda, also known as the mean of the distribution, which represents the average number of events or outcomes per unit time, distance, area, or volume, okay? So intuitively, we can say that in order to specify the Poisson distribution, we only need to know the mean number of occurrences, okay? Now let's take a look at the formal definition for Poisson distribution. A random variable x has the Poisson distribution with parameter lambda if its PMF is given by equation 4.1, okay? So this is how the PMF of Poisson distribution will look like, okay? Now let's take a look at some properties of Poisson distribution. If x has the Poisson distribution with parameter lambda, then the expectation of the random variable is equal to lambda, the parameter, and the variance of the random variable is also equal to lambda. So with this one, we have the mean and the variance to be the same, okay? This is still equal to the parameter lambda. And we can also have the moment generating function defined in this form, okay? All right, now before we take an example, let's take a look at some theorem. So in this theorem, we want to look at the Poisson approximation to binomial distribution, okay? Now, occasionally, one may encounter a binomial random variable for which n, or the sample size, is very large, okay? So if binomial tables do not exist for this value of n, then calculating probabilities associated with the variable becomes very tedious. So in this case, the Poisson distribution can be used as an alternative to approximate the binomial distribution. And this is based on the convergence of the binomial distribution as n, or the sample size becomes large, and p, that's the parameter of interest, becomes very small, okay? So this is a theorem. Let x be a binomial random variable with parameters n and p. If n approaches infinity and p approaches 0 in such a way that np is equal to lambda remains constant, then we can say that the limit as n approaches infinity of the PMF of our binomial distribution will be approximately equal to the Poisson distribution, okay? There's a proof to this, guys. I'm going to skip that, okay? All right, so now let's take a look at an example. In a certain country, the average number of deaths from COVID-19 disease has been 10 per year. If the number of deaths from this disease has the Poisson distribution, we want to find the probability of observing at least 2 deaths from the disease in 3 months. And secondly, the probability of observing at most 1 death from the disease in 2 months, okay? All right, so let's take a look at the solution. Let x, this is for the first part, let x denote the number of deaths from the disease in 3 months. So on average, we are going to have 2.5 deaths from the disease in 3 months, okay? We know that from the question, we were given 10 deaths per year, and we know that 12 months is equal to 1 year. So for 3 months, we are going to use this conversion, and this gives us 2.5 deaths from the disease in 3 months. So hence, x has the Poisson distribution with mean equal to 2.5, okay? So therefore, we can define the PMF for this random variable in this one, okay? So here we go. So we want to find the probability of observing at least 2 deaths from the disease in 3 months. And we can use a complementary rule. This can be written in this one. Okay, so we know if it is less than 2, then it means that the x can pick only 0 and 1. Okay, so when x is 0, using this, we obtain that. And when x is 1, using this, we obtain this. Okay, so once we compute this, we obtain that. And this is approximately equal to that, okay? So basically, we can states that approximately there is 72% chance that you are going to observe two deaths from the disease, okay, in 3 months, okay. Now let's take a look at the second part of the question. So in here, let me check. I want to look at the probability of observing at most one death from the disease in 2 months, okay. So let Y denote the number of deaths from the disease in 2 months. On average, you are going to have 5 out of 3 deaths from the disease in 2 months, okay? Because if from the question we are given 10 deaths per year, and we know that 12 months is equal to 1 year, then for 2 months, we are going to have use this conversion to get this, which is 5 out of 3 deaths from the disease in 2 months. So we can state our PMF in this form, okay? For this random variable Y. So now I want to find the probability of observing at most one death from the disease. Right, and observing at most one death can also be written in this form. It means that Y can pick value 0 or 1, okay? So when Y is 0, using this PMF formula, we are going to obtain this. And when Y is 1, using this PMF formula, we are going to obtain this, okay? So once you compute this, you obtain that, which is also approximately equal to that, okay? So it means that there's approximately 50% chance that we are going to observe at most one death from the disease in 2 months, okay? All right, so this is a trial question. I will leave the solution in the description of this video so you can check it out. Please, if you find value into this tutorial video, don't forget to subscribe if you have not. And for your notice, there are no charges anytime you subscribe, okay? It is free of charge. So please kindly subscribe if you have not to support this channel. And thank you.